Hello, everyone. Today we are going to talk about the latest developments in machine learning in Combos. So we are going to see what are the new features that have been developed for version 22. A small summary of what is currently available concerning machine learning in Combos and also ANSA is that the optimization tool was coupled with the DM, the data management system, which means that we can now use the optimization tool to create a design of experiments, use them as our data sets that are directly saved in the DM system as simulation runs. This, of course, helps with handling data within Convos that will be used for training of our machine learning models. The ML Toolkit, which is an add-on in our beta software suite, it makes training and use of machine learning and prediction models possible. This enables the analysis of cases of models' behavior in a fraction of the finite element analysis time, utilizing the latest machine learning libraries of Python, and it is synchronized for Windows and Linux machines. So the training of predictive models is achieved by employing past data, taking advantage of previously acquired knowledge with a straightforward and uncomplicated process. Similarly, prediction of new designs behavior is a simple process. Two types of ML algorithms models are available that can predict single scalar values and 2D values and 3D results as well. The first one is the data-driven design variable-based algorithm. This one can be trained based on models' design variables and selected responses. These responses can be key values, so single scalar values. They can be 2D curves or 3D field results. For the training phase, the algorithm will learn experiments that have common design variables and some sort of objective or response. A DV-based predictor, as we call it, can predict any key values, 2D plots or 3D field results based on design variable values as an input. The second type of algorithm is the simulation-driven feature-based algorithm, which is a cross-model approach trained based on the finite element model body in white and the modes of the first torsional, vertical, and lateral bending. Inputs of this machine learning model are geometric and engineering features extracted from CAE data, from the FE model of the body in white. The evaluated features are related to model shape as well as materials, connections, etc. Finally, one more important aspect that was developed was incremental learning methods that have been implemented in our software that allow for addition of new training data to the existing predictors at a lower computational cost that would take than it would take to retrain new predictors from scratch. Okay, so this was the summary. So going on to see step by step these subjects, the first thing is that the updates in machine learning include the training and prediction of scalar field primary and derived results for all states. So we see here that on the left of our screen, we have an animation of the FE results, and on the right, we have a prediction. So this has been done by training our machine learning algorithm on these 3D results that contain these sort of displacements that we see here, or deformation. We can also see a different kind of results that have been trained on at the same time. We can see some stresses here, and in this video we can also see some plastic strains. Again, the left side is the FE results and the right side is the prediction, and we can see that we have very good accuracy. Some more results of the same. As I mentioned, 2D plot results can also be used for the training and prediction. In this case, we have seen some results from the same analysis, some normal force and some kinetic energy. Again, here the prediction is red and the FE results is the blue. We see that we have a very good accuracy. So this was possible using a new training wizard that is available in Convos. In this wizard, we can select one of the existing DOE studies that have been imported in Convos, either via ANSA or another way. We can pick which type of results we want to use for our training. In this case, we have, as you see, the 3D results and the 2D results with a menu for selecting the correct result file. This, of course, will be used in order to check what results are available, and then we can pick the results that we need for the training. We can see that key values are the single scalar values that come up as responses from ANSA, it could be, or from Meta as single values, field results, and also curve results. We give a name to the predictor, and then the training starts within Convos in an asynchronous way, so Convos is still active to work. Additionally, for the feature-based machine learning, bending modes of vertical and lateral type can now be used for training and prediction with the feature-based machine learning. So along with the first torsional mode, the ANSA session that we had in our previous version, the wizard here requires 6 points, additional 2 points in the middle, middle of our body in white. So with this wizard, we create, a post-processing item in here that contains a specific session that is distributed in the package. So after each iteration of a normal modes analysis, in this case, the Meta will launch in the background, and the session will calculate the first torsional, vertical, and lateral bending mode frequencies and create key value responses for these. So this means that when we perform then the ML training inside Convos, we will be able to use these responses for the training. Once we perform the training, we can use one predictor to make predictions for new models. And the predictions will look like this. First torsional value prediction with the variance, vertical bending with its variance, and also lateral bending again with its variance. And we can see some sort of animations for these different type of modes. So a new also addition was that we have added functionality to allow design variable-based prediction to be performed on similar models to the ones that we have trained. So a new model with no designed variables can be the input of an existing predictor. So what we see here is that we have a trained model. This was a crash model that had design variables for the thickness of this rail. And then we input a different model, different type of analysis, maybe with no design variables or different PIDs here. There is a mapping process that takes place, and then we have a window that shows our existing and trained design variables, how much they have been mapped within our new model. So we see the similarity factor here. If the similarity factor is good enough, then we can calculate new values for our new model. the adaptation is done in the new model as well, based on the mapping, and new values can be added in our predictor, factoring in the differences, and make a new prediction for this slightly or different or similar model. From this prediction, we can use ANSA to open the modified new model with the created optimization task, with the created design variables, and perform more DOEs using this model. Create this way another version of our existing model. Additionally, a new feature was that in the existing DM that was created using the ANSA optimization tool, we can launch a new DOE study directly from Convos and use the DOE algorithms that are available in ANSA from Convos to create new DOE studies. So ANSA, when we press finish, ANSA will run in the background and create and save the new simulation runs in the DM in a new DOE iteration. As we can see here, this is a new DOE iteration. So there is no need to start again the ANSA model and perform the DOE study from there, and this helps with the creation of new DOE studies within Convos. A new wizard is also being added in the actions for importing parametric data. This was developed in order to help the manipulation of parametric data from other sources other than ANSA. This means that existing parametric DOE studies in an Excel format, like this one we see here, can be imported in Convos. Through the wizard that we see here, we select the Excel or CSV file. The columns are highlighted for designed variables, and we can assign design variables responses and also optionally pictures and solver files or ANSA files, for example. So we can assign a category for each of the columns that we see here. And then when we press finish, a DM structure will be created in the format that is compatible with our design variable based training. So we can see here that we have new simulation runs with reports, key values with images, key values that we can use as responses in our training, and then also our model contains design variables as well, which means that is ready for machine learning training of the DV-based type. So these were the news that I have for machine learning. There is more information in our website if you are interested. So let me know if you have any questions.